This is a May-June 2022 variant 42 question. For this question involves resonance and phase difference. For A, we have to state what is meant by resonance. This question carries 2 marks. To get the 2 marks, you must say that when resonance occurs, the oscillations of the object occurs at maximum amplitude. Then number 2 is when the driving frequency is equal to the natural frequency of the oscillating object. Then for part B, figure 4.1 shows a heavy pendulum and a light pendulum, both suspended from the same piece of string. The string is secured at each end to fixed point. This is a fixed point. Both pendulums have the same natural frequency. The heavy pendulum is set oscillating perpendicular to the plane of the diagram. As it oscillates, it causes a light pendulum to oscillate. In this question, in this part, figure 4.1, the heavy pendulum is acting as a driver. And then the light pendulum is acting as the vibrating object or oscillating object. The heavy pendulum is forcing the light pendulum to oscillate by transferring energy to the lighter pendulum through the string. This is how the energy gets transferred. The energy is transferred from the heavy pendulum to the light pendulum through the string. The frequency of a pendulum is given by this formula, 1/2 pi square root of g divided by L, where g is the acceleration due to gravity and L is the length of the pendulum. Therefore, the frequency of the heavy pendulum is equal to the frequency of the light pendulum. These two pendulums have the same frequency. This is because the length L of the heavy pendulum is the same as the length L of the light pendulum. Therefore, both the pendulum have the same frequency. And then the heavy pendulum is forcing the lighter pendulum to vibrate by transferring energy to the light pendulum. The heavy pendulum transfers energy to the lighter pendulum through the string, as we explained just now. Then in figure 4.2, figure 4.2 shows the variation with time t of the displacement of the pendulum for 3 oscillations. This is the first oscillation. This is a second oscillation. And then this is a third oscillation rate. This is a displacement time graph. From the displacement time graph, we can get 2 important information. The first information is the period of the pendulum. You can see that the period of the heavy pendulum is the same as the period for the light pendulum. The other information you can get from this graph is the amplitude. This is amplitude for the light pendulum, and this is amplitude for the heavy pendulum. You can see from here that the amplitude of the heavy pendulum is 3 times the amplitude of the light pendulum. And also, the oscillations of the heavy pendulum is different from the oscillation of the light pendulum. There is a phase difference. The phase difference can be calculated based on A or calculated based on your B, which is this one. The variation with time t of the displacement x of the light pendulum is given by this formula. Where x is in centimeter and t is in seconds. We have to calculate the period t of the oscillations. In order to solve this question, we need to compare x equals to 0.25 sine 5.0 pi t to the general equation for displacement, which is x equals to xo sine omega t. X is the displacement, xo is the maximum displacement or the amplitude, and omega is the angular velocity. So comparing the 2 equations, we find that the amplitude of the light pendulum is 0.25 centimeter, and omega equals to 5.0 pi radian per second. Once we know omega, we can find the period because the formula relating the period to the angular velocity is given by t equals to 2 pi over omega. So substituting your omega into the equation will give you 0.4 seconds. Then in part 2, on figure 4.2, label both the axes with the correct scales. Use the space below for any additional working that you need. The displacement scale, which is the vertical scale, is labeled at minus 1.0, minus 0.5, 0, 0.5, 1.0 on the 2 centimeter thick. And then the horizontal time scale is labeled as 0.2, 0.4, 0.6, 0.8, 1.0, 1.2 on the 2 centimeter thick mark. This is how we label the axis. On the horizontal time axis, we label as 0.0, 0.0, 0.2, 0.4, 0.6, and this is 1 centimeter. This is 1 centimeter vertically. This is 1 centimeter horizontally. That means in the horizontal scale, 1 centimeter or 1 centimeter is here, represents 0.1 second. And then on the vertical scale, which represents displacement, 1 centimeter represents 0.25 centimeter. That means the displacement of the light pendulum is 0.25 centimeter. The displacement of the heavy pendulum is 3 times larger. It will be 0.75 centimeter. In part 3, where we determine the magnitude of the phase difference between the oscillations of the light and heavy pendulum. Give a unit for your answer. In order to do this question, we need to relate a wavelength to a cycle. We need to relate a wavelength to 360 degrees or 2 pi radian. The formula for phase difference is equals to 2 pi times delta t divided by capital T. Delta t is the time difference between 2 objects in 2 points in phase, and then capital T represents the period. So there are 2 ways to calculate the phase difference here. You can calculate based on A or based on B. If you calculate based on A, the phase difference equals to 2 pi, 0.1 divided by 0.4, which will give you 1.6 radian. And then if you calculate based on B, you will have to substitute the phase difference equals to 2 pi, 0.3 divided by 0.4, which will give you 4.7 radian. This is a summary of the facts that you must know to solve this question. Number 1, we need to understand that resonance involves a maximum amplitude of vibration. Number 2, understand that resonance occurs when the vibrating object is forced to vibrate at its natural frequency. In other words, resonance occurs when the driver frequency of the driver is equal to the natural frequency of the vibrating system. Then number 3, there's usually a phase difference between the driver and the vibrating system. You must be able to calculate this phase difference in terms of A or B. This is your A and this is your B. Then number 4, one of the equations relating displacement x and time t is x equals to x0 sine omega t, where xo is the maximum displacement or amplitude and omega is the angular frequency or angular velocity. Then finally, number 5, you need to know the data you can obtain from the displacement time graph of an object undergoing simple harmonic motion.